Hello and welcome to the first lesson of Unit 0 in our Grade 10 academic math class. This is Exponent Laws. The first unit is really designed to be a review of Grade 9 as well as checking you have the skills necessary to be successful in Unit 1 and Unit 2, etc. So let's jump right into Exponent Laws. Now if we look at the first paragraph, it talks about powers, and powers are an essential part of understanding exponent laws. If you look at the paragraph, it says a power consists of two parts, a base and an exponent. The base tells you which value to repeatedly multiply, and the exponent tells you how many times to perform the multiplication. So if we have a quick look, in this case here, what we have is 3 to the exponent 4, 3 of course being our base, and 4 of course being our exponent. And there's two different ways that we can write this. One is what they would call exponential form, and you see that over here. That's 3 to the exponent 4. And to sort of write this thing out just reinforces the definition, which is 3 is your base, that tells you which number to multiply, and you are going to be multiplying it by itself 4 times, and that refers to the exponent. So let's have a look at example number 1. Now these are already filled in, so you can just copy them as I talk through them. 5 to the exponent 4. The first part of example number 1, the base is 5, the exponent is 4. It stands in contrast to the one underneath it. What you'll notice is it's negative 5 to the exponent 4. And the base is the entirety of the number that is having the exponent raised from it. So because the brackets encompass the entire negative 5, that's going to be our base, negative 5 to the exponent 4. If we scooch over to the other side, what you'll notice is, and I've sort of written on it already, we have another negative 5 to the exponent 4, but this time the negative 5 is not actually in the brackets. So that 4, that exponent 4, is only being applied to the 5. In essence, it's like writing negative 1 times 5 to the exponent 4. So you can see that if I write it in a slightly different way, it's clearer that 5 is the base and 4 is the exponent, as you can see written here. If we look at 2x to the exponent 3, again, that 3 is only being applied to the thing it's bumping into. In that case, or in this case, it's the x. The 2, it's more like 2 times x to the exponent 3. So the base is x, the exponent is 3. Stands in contrast to our final part, the final example in example 1, where you have 3x, all in brackets, whole thing to the exponent 4. So the base is the entire thing the 4 is bumping up against, 3x. So 3x is the base, and the exponent is 4. Hopefully that makes sense. Let's have a look at some of the exponent laws you should remember from grade 9. The first exponent law is, and I'm just looking at the top here, we have x to the exponent m times x to the exponent n. How do we deal with multiplying powers with the same base? We keep the base and we add the exponents together. So it would be x to the exponent m plus n. And if we look over here, that explanation I just said out loud, in this case, if we have x to the exponent 4 times x to the exponent 10, the answer will be, x, 8 to the exponent 4 times 8 to the exponent 10. That's going to be 8 to the exponent 4 plus 10, which will give us 8 to the exponent 14. I'm just adding those two numbers together. Similar idea if we are dividing powers by the same base. If you have x to the exponent m divided by x to the exponent n, it is going to be x to the exponent m minus n. So if we look at our example, if we have 3 to the exponent 30 divided by 3 to the exponent 16, that's going to be 3 to the exponent 30 minus 16. And that's going to give us 3 to the exponent 14. I'm just subtracting those two numbers. A final one that sort of builds on that is if you have a base, x to the exponent m, whole thing raised to another exponent, we call this a power of a power, we are going to multiply the two exponents. So in the case of a power, so an exponent being raised to another exponent, we are going to multiply those exponents. So here we have 2 to the exponent 6, whole thing to the exponent 3, that will be 2 to the exponent 6 times 3, which is 2 to the exponent, oh, that's an ugly 8, 2 to the exponent 18. So those ones, they kind of come in a little package, and then we start to look at some different variations. What if we have a base that is a rational number, meaning a number that has both a numerator and a denominator? what you'll do is apply that exponent to both the numerator and the denominator. So x over y, whole thing to the exponent m, you can write that as x to the exponent m over y to the exponent m. You'll see that this m is being applied to both the top and the bottom of the fraction. So let's look at how that goes. If we have x to the exponent 4 over y to the exponent 2, whole thing to the exponent 3, what we have is we're going to distribute this 3 to the numerator. So you have x to the exponent 4 times 3 over, and now we're going to distribute it to the denominator, y to the exponent 2 times 3. And using the exponent law we did above, power of a power, we're going to multiply these things together. That's going to give us x to the exponent 12 over y to the exponent 6. And that's as simple as it can get. Let's look at a more complicated base. So if you have a base that's comprised of a few different parts, if you have an a, x, y, and that's our whole base being applied, or having the exponent m applied to it, you would, similar to the example above, we're going to distribute that m to all three, what I'm calling components of the base. And you would have a to the exponent m, x to the exponent m, y to the exponent m. Let's work that example out. So here we have 2xy to the exponent 5, whole thing cubed, or to the exponent 3. So we are going to apply that exponent of 3 to each component of the base. So did the 2 first, 2, now to the exponent 3, x to the exponent 3, and lastly y to the exponent 5 times 3. And let's simplify this. Now, if you're given something like this, 2 to the exponent 3, we can actually figure that out. Remember that that's going to be, I'll just write that down here in a different color. This is going to be 2, that's 2 times 2 times 2. So that's going to give us 8. That x to the exponent 3, we're just going to leave it. And we have now y to the exponent 5 times 3, or y to the exponent 15. Let's look at exponents of 0. Anything to the exponent 0 is going to be 1, any base at all. So in this case, in the example, we have y to the exponent 0 equals 1, and we flip over to the other side, negative 201, whole thing to the exponent 0, anything to the exponent 0 is going to equal 1, no matter what. Let's look at negative exponents now. So a way of working with a negative exponent, if you have a base that's not rational, and it just doesn't have a visible denominator, just remember that this is actually going to be an x. Let me change up my colors here. This is actually going to be x over 1. And the way that you deal with a negative exponent is to invert the base. So flip the base upside down, and then all of a sudden you end up with a positive version of that exponent. There's a way to explain this. I'm not going to do it in this video just for the sake of saving some time, but you could also write this as whole thing 1, oops, let's get that out of there. We can write this as 1, oh, making a mess here. This can also be written as 1 over x whole thing to the exponent n, if you prefer. Obviously, 1 to the exponent anything is just going to give you 1, which is why we've sort of done a little bit of a shortcut here. But let's have a look at this example. So what we have here is negative 6 to the exponent negative 3. Now remember, this is a negative 6 over 1. So the way that we deal with a negative exponent, because we don't really like to have negative exponents around, is to invert the base. So that'll be 1 over negative 6, whole thing to the exponent positive 3. So this act of inverting the base has changed the sign of our exponent. Now it's not super awesome to have a negative exponent, or sorry, a negative value in our denominator. We're just going to ride by that for now. And now let's evaluate this. So what is 1? Remember, I'm distributing this 3 to both the numerator and the denominator. So I have a 1 to the exponent 3 over negative 6. And that would be bracketed negative 3, or to the exponent 3. The reason that that denominator is bracketed is because it's its own little entity in the denominator of this fraction, this rational base. So let's work these out now. What is 1 times 1 times 1? That's going to give us 1. And negative 6 times negative 6 times negative 6 is going to give us negative 216. Now if you wanted to be just a little more proper, you could write this as 1 over 216 and kind of just feel the negative just out front, sort of giving the whole fraction that negative sign. All right, we got one more here in this table. How do we deal with a rational base to a negative exponent? Same idea here. we're going to invert the base, and the act of inverting the base will result in a positive exponent that of course will be applied to both the numerator and the denominator. So let's have a look at this example. You have 3 over 2 to the exponent negative 4. So the way that we make this exponent positive is to invert the base. There we have 2 over 3 now to the exponent positive 4. And I'm going to distribute that 4 to both the numerator and the denominator. So I'm going to have 2 to the exponent 4 all over 3 to the exponent 4. Now again, we can do this math in our heads. 2 to the exponent 4 is 2 times 2 times 2 times 2, which is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. All over, this one might be a little bit harder, this is 3 times 3 times 3 times 3. So it's 3 times 3 is 9, times 3 is 27, times 3 is 81. And that is sort of our introduction. After this, we're going to move through some examples where we're going to be applying these exponent laws that we've looked at, and we're going to make that the second part of this video. So come on back for part 2, and we'll go through some of these examples.